This is video number 14 in the series on concrete slabs. This video will deal with flat slabs. A flat slab is a slab supported by columns or walls, but the floor has a uniform thickness and there are no beams. You can have a local thickening of the slab at the location of the supports. This thickening can have different shapes. Or it can also be without any thickening on the slab. So you will have really a flat slab supported by the columns. There are no beams. Or there is locally a large portion which is thicker than the slab itself. To calculate floor slabs like that, you can use a simplified method of an equivalent frame. So when you have different levels, different stories, then you can subdivide the slab in strips over the column, like it's mentioned here. And the strip has a width of Ly and a length like it is mentioned here. And you can calculate the bending moments as a multiple degree indeterminate frame. Once you got the bending moment, then you have to distribute the bending moment over the strip of your calculation. This method is well explained in this keuraanbeveling and is well recommended. Bending moments are then distributed over the strips to determine the needed reinforcement. For the hogging bending moments, you have a repartition or a distribution according to the figures mentioned here. And for the sagging bending moments, you also have a distribution with the figures mentioned here. And the width of the strip where you redistribute the bending moments is given by this quantity. Eurocode 2 Part 1.1 gives also a distribution method of the bending moments. In your frame, you have, for instance, a total bending moment of MT and gives you a reinforcement equal to AT over that strip. So the Eurocode 2 says this needed reinforcement on the at the hogging side of the slab must be distributed, half of it that you find here, half of it must be redistributed over the columns at a distance of 1/4 of the net span Ly. The design is of a flat slab floor is really an iterative process. You cannot base your design on a fixed formula giving you the thickness of the flat slabs and the thickening of the slabs and things like that. So Ritsen and Van Wanbeek gave a good start, a good impression of the needed thickness of a flat slab floor. And when the distance between the columns is Lx, then you can start off with a column thickness of 1/20th of the span, or or it must be bigger than 1/15th of the of the height of the column, or the height of the floor, the floor height, and it must be bigger than 30 centimeters. You can start with that. Then for the slab itself, the flat slab itself, it should be the thickness should be more than 15 centimeters, and then you can start with the dimensions of the thickening of the slab, the capitals, and with all those estimates are given here. This gives you a good start, and then you can run your iteration process of calculating your flat slab.